Hello everybody, today we'll be doing lab activity number 6. It's 7.7 and we have Caesar Cipher, so we're going to be decoding secret messages. Very exciting stuff. And so you've got some historical context here on the Caesar Cipher, but basically it's just a mild form of encryption using an alphabetical shifting system. So for example, if we wanted to encrypt ocean by shifting the alphabets by 5 in the leftward direction, I guess depends on your perspective. If we look at our keys, we have the plain text just has the normal alphabet, A to Z, and then our shifted text just starts 5 over to the right, and then we take whatever we have removed from the beginning and just kind of slap it on the end over here. So if you run the program and you give it some input that is not ciphertext, then everything except for the zero shift will give you nonsense, unless there is some crazy miracle for which the Caesar cipher of your plain text actually um, becomes more like different plain text at some other interval, but that is unimportant, right? So yeah, here you can see hello is the plain text, and since it's not encrypted, we just get garbled nonsense for anything by shifting that's other than 0. And so what we want to do is we want to write this function that shifts the text. So each time in the main, it's just calling that function and then displaying this nice little output scheme. So here we have a cool opportunity. We get to figure out the return type for ourselves and the parameters. So that is what we are going to do first. So we're not even going to worry about this right now. So let us write our shift the text function. So here our goal is just to take a string and we want to shift it by the desired amount. So reading the prompt is very important here and gives us a lot of nice hints. So we're given an array of characters and a shift value. So these two things you can think of as being given to the function, right? So we want to include these things as parameters for sure. That's not to say there won't be more parameters, but we know that we're going to be using these in our function. So we can have, so we want an array of characters, so it would be a char, and so generally we can choose our identifiers, right? And we should. But here our main is written for us. So let's go ahead and take a look at what identifiers are being used for our character arrays in the main program. So we have starting text and shifted text. So we're going to be using both of these, not necessarily both of them in our function, but if we are going to be using in our function, we should use the same identifiers. Just in general, it's good convention when we are writing functions to kind of have our parameters and our local variables inside of main match up like puzzle pieces. So yeah, so we're going to want our starting text. Oops, I went up too far. Want an array of characters that represents our starting text. Okay, and then we're also going to want then our second parameter is going to be the integer shift value, right? You can't shift by 1.2 or something like that, so we know it's going to be an integer, and we can just call that shift value. Okay, cool. So what do we want to do with shift the text? We want to shift each character in the original text by some amount, storing, namely, shift value, and storing the result into the shifted text array. So we want to store some information into a specific object. So it's the way that this prompt is giving us instructions implies that the shifted text array already exists. So we could do this two ways. We could either return the array, so we could have the return type be a character array, or we could pass the array by reference, and we'll talk about how that is implemented with C strings and character arrays here soon. But yeah, those are our two possible approaches. And the way I'm going to do it is I'm going to go ahead and just pass it by reference, right? So the thing about using character arrays is that they are kind of, you can think of them as being passed by reference by default, right? Because C++ is saying, okay, well, a character array is just a pointer to some place in memory that's going to contain an array of objects that are contiguous in memory at that location. So we actually don't need to do anything fancy to specify that the array can be modified. It's because it's passing a pointer by default. So we can have our starting text, our shift value, and we can have our character array shifted text. Awesome. So those are definitely the parameters we need. And we're going to want to make this a void function since it's not returning anything. But like I said, if we wanted, we could return this, but we'd have to modify main a little bit. I mean, we're going to have to do that anyways to pass in our arguments, but that is beside the point. So we have this. Again, whenever we have really long function definitions like this, we just kind of want to make the little bit more compact here by just moving all of our parameters to a new line. And this way we have much more legible code. And then it's good, especially when we use this kind of syntax for our parameters, to include something in the header, or since we have our header given to us, just next to the parameters themselves, about what it is that these parameters are for. It's pretty straightforward here. This is just the text that we're given, and then we have the integer shift value, how much to shift the text by, and then our actual resulting text. Okay, cool. So now we want to get into the body of the function, and here we already have our outline written for us, so this is nice. So we want to loop through each character in the C string starting text. So that's simple enough. If we want to loop over some object with a known number of, if we want to loop over some container with a known number of objects, then we can just use our for loop. So and say for some integer I equal to 0. And then what do we want to do for our condition here? Right? So at what point do we know that we've reached the end of a C string? Well, if you recall, all strings are ended with a null terminator character, right? So it just looks like this. Right? Or maybe it's the backslash. I think it's the backslash, but that's inconsequential. You have the null terminator. No, it doesn't look right. But yeah, so a string is just a character array with a null terminator at the last index there. So if we say something like some string is named hello, then this is just exactly equal to a character array, which looks like this. So we can say H E L L O, and then our null terminating character at the end here. Right, so those are the same thing. You can't, I'm not sure if you can use this syntax in C++, but this is just for instructional purposes, right? So we know that we've reached the end of our string when the character at the given index is equal to the null terminator, right? So rather than saying, okay, less than the length of the string, if we know that, we could use that. But we want to just loop until we reach a null terminating character. So that will be when the starting, oops, why did I write starting twice? Starting text at index I. We're using the square braces to access the element at this position. And we're saying, okay, so well, this is not the null character. Aha, so it is the backslash. Okay. There we go. Well, this is not the null character. We will continue looping through the string and incrementing our counter. Okay, nice. So we have step 1 taken care of. We've got our looping header defined. So now, here, let's move this all inside because that's what we're doing. We're doing all of this from within the loop. Ooh, that's ugly. Oh well. We'll live with this for now. So when the character is an alphabetic character, we want to shift it by adding the shift value. So how do we check if a character is alphabetic? Well, you might think that is difficult, and it's not fun. So we will just take care of that by using a library function. I think it is alpha, right? So isAlpha takes an argument of a character, and it returns true if it's alphabetic, and false if it is not. So we say, okay, we want to check, meaning we want to use an if statement, if the character is an alphabetic character. So we need to have some sort of way to keep track of the current character. If we want, we can just keep using starting text at position I, but that makes the code less legible, right? We want readable code. So we'll have some character variable, call it C, and we will just set this equal to the starting text at position I. And in that way, each iteration of the loop, our character C will change. So we're going to say, okay, if C is alpha, so then what do we want to do? We want to shift it by adding the shift value. So we want to take the character and shift it over the proper amount. So here we have to know a bit about the ASCII table, right? So all characters are denoted with some index in this ASCII table, and alphanumeric characters are a bit higher up there. So what we can do is we can use, we can reduce. So I think, for example, lowercase a starts at like 70 or 80 something, and or something like that in the ASCII table, and we want to get it into a range where we can add the shift value, right? So, and we're going to have to use modular arithmetic to do this. And so what happens if we have an ASCII value of like, I don't know, 80 something for one of our characters, and we try to worry about this wrapping edge case, right? Because after we get to Z and a shifted key, then we go back to A. So we're going to need this modulus operator. But if we do that, if we try to modulus by the amount of the alphabet, so 26 characters, like seems natural, then we will get an improper remainder based on the fact that we are not actually between 0 and 26. So the first thing we want to do is get ourselves within that range. So to do that, we can just subtract by the ASCII value of the first alphabetic character, right? So our character is C, and since we know C is alphabetic, then we know that we will be between 0 and 26 if we subtract the ASCII value of the first alphabetic character. So we'll say C is equal to C minus, so pointer arithmetic, right? So we're shifting over the character that we're dealing with by the ASCII value of A, because A is the first alphabetic character. Right, so that's what we want to do here. And then we want to add the shift value to it, right? But what happens if we are at Z, right? If we try to add a shift value to Z, then we will get an uppercase letter by accident, which is not what we want. So what we have to do is we have to add the shift value, and then we have to compute our modular arithmetic. And since, thanks to this step, we got ourselves within the range that we wanted, so this makes our character somewhere between 0 and 25. Since we've done that already, we can go ahead and so we can add our shift value, so we can say, okay, C is equal to C plus shift value. So now we have something that is between shift value and 25 plus shift value. So in order to get this where we want it to be, we can just take the modulus by 26. Right? Because, for example, let's say our character is Z. If we have a shift value of 1, or let's use 2. If we have a shift value of 2 and our character is Z, then Z plus the shift value is going to be some, so C would be equal to 25 in this case. So 25 plus 2 is going to give us 27. And if we take the 27 modulus 26, then we get 1 back. So that's going to give us B as desired, right? Well, not quite actually, right? Because now we're going to have just 2. But we need to get this back to our ASCII value now that we've shifted it and converted it properly. So in order to do that, we just have to go ahead and add our first alphabetic ASCII value back onto our character, right? So this is actually performing the shifting. And this is going to revert range back to standard ASCII. Nice. So now we've appropriately shifted the given character at index I by the shift value. So to recap, right? So the first thing we want to do is when the character is alphabetic, so we have to check if that is the case. We want to shift it by adding the shift value. And so the natural thing that we probably all jump to is just saying, okay, well, C plus equals shift value, right? And so that must change, that must shift the character by the desired amount. But unfortunately, we have to take into account that the way that characters are stored numerically has to do with ASCII values. So in order to do this and take care of our wrapping problem, we have to go ahead and change the range to be within 0 and 25, rather the standard alphabetic ASCII value range. And we do that by subtracting the value of the first alphabetic ASCII character. And then we will end up between 0 and 25. And then we gotta perform the shift. So we'll add the shift value. And then if the shift value exceeds 26, then we will just take the remainder, and that will wrap us around the alphabet. So now that we've done our shifting, we have to get it back into standard ASCII, and now C will actually be equal to the desired shifted character. Next, we want to store the resulting character in its proper spot in the shifted text C string. So to do that, all we have to do is access shifted text at a given position, and in this case we want to do it at exactly position I, and we want to go ahead and set its value equal to this newly shifted character. So we would say shifted text at index I. So we are accessing the memory. We're saying, okay, go into this this character pointer, this array, and we're going to go to the offset of index I, and we're going to change the memory there and assign it with the value of C. Right? So again, just to reiterate, we don't need to use a reference parameter because arrays are pointers by default. Right? So shifted text is a pointer, so we are already directly accessing the memory when we make this call. So we're accessing the memory and we're saying, okay, make the memory at this location be written with C. So now let's look to main, right? So we have our starting text and we have our shifted text, both of which we use the same identifier for in our function so that it's clear that these are the variables that are being passed into it. And we're using our global constant max word size to initialize these strings, right? So when we are declaring character arrays or arrays of any kind, we have to allocate a fixed amount of memory for it ahead of time, right? So in this case we have 81. It's just kind of like a generic value that's often used for strings. We're going to have, and there's that extra one space for the null terminator, right? So allowing 80 characters in our string here. So here we're allocating memory for both of these arrays, these character arrays. So they're both going to have whatever garbage is contained at that memory by default, since we're just declaring them, but the space for them now exists in our program. And then of course we're reading in the starting text from the user, and then we are going to shift it using our function each individual time for each shift value. So we're going to shift it all possible times. And so all we have to do here is we just have to pass in our arguments. So we've got starting text as our first argument, and we have our shift value, which is just shift value here, and then we are going to also pass in our shifted text. And so this way, shifted text will be updated after each call of this function, so that when we go ahead and output it here with this special formatting, we are going to get our shifted text, right? And that is kind of all there is to it. C strings are a very complicated topic, I think. I think pointers are very difficult to get a grasp on for beginners, and understandably so, right? So to aid you guys in that endeavor, I may be posting to Piazza with a kind of guide on character arrays and C strings and stuff like that. That is all there is to it. So now, if you want, if you were so inclined, you could come up with some ciphertext or some plain text and encrypt it using a basic Caesar cipher. So have fun with that, and I will see you next time.